Welcome to True Projects. In this video, we are going to explain about a project titled A Knowledge-Based Clinical Decision Support System Utilizing an Intelligent Ensemble Voting Scheme for Improved Cardiovascular Disease Prediction. The introduction of the project underscores the importance of extracting the valuable knowledge from the extensive amount of medical data generated by the healthcare institutions and hospitals. To reveal the hidden pattern within these datasets, data mining techniques are utilized. Medical data mining, in particular, aims to uncover the meaningful patterns and valuable information within the medical datasets. The project emphasizes the potential of intelligent data mining technique to transform these datasets into the actionable insights. While data mining has shown its effectiveness in various fields such as of marketing, business, and banking, applying these techniques to the medical dataset hold a significant potential for discovering the valuable insight in the healthcare industry. The project aimed to introduce a clinical decision support system that utilizes the knowledge and incorporate an intelligent ensemble voting scheme to improve the accuracy of heart disease prediction. The proposed framework is designed to achieve more accurate prediction of heart disease regardless of the dataset used. The project evaluates the performance of the proposed ensemble scheme against the individual classifiers and 5 other alternative ensemble schemes using the various parameters to showcase the effectiveness of the approach. The evaluation of the result demonstrates the proposed ensemble scheme outperforms the individual classifier in the term of average accuracy. These are the basic requirements that are needed to build this project. The software requirements: Python IDEL with version of 3.7 or Anaconda with version of 3.7 or Jupyter or Google Colab. Hardware requirements: operating system as Windows or Linux, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. To know about the flow of project, the various tasks are breakdown, and these are information that need to be developed one by one. And the first one is importing the libraries. In this step, the necessary libraries for data manipulation and analysis are imported, and these libraries include like of pandas, numpy, and sklearn. And the second one is importing Cleveland dataset. The Cleveland dataset containing the heart disease related data is imported. And the third one is importing the Hungarian dataset. The Hungarian dataset which related containing of the heart disease is imported. And the fourth one is importing the Switzerland dataset. The Switzerland dataset which contains the heart disease information is imported. And fifth one is importing the Long Beach dataset. The Long Beach dataset, another dataset with the heart disease dataset, is imported. And the naming the column names. The columns of the dataset are named appropriately for better data organization and the analysis. And the seventh one is checking for the missing values. Missing values in the dataset are to be identified to address the potential data quality issues. And the eighth one is replacing the missing values with the mean and the median. Here, the missing values are handled by replacing them with the mean or median of the respective columns to get the accurate value of the replaced one. And applying the algorithms on the 4 different datasets. Several machine learning algorithms are applied to the 4 heart disease datasets to build the predictive model. And the first one is SVM. SVM means of support vector mission is a powerful supervised learning algorithm used for classification tasks. It works by finding the optimal hyperplane that best separates the different classes in the data. And the second one is Bayes. Bayes is a probabilistic algorithm based on the Bayes theorem. Despite its simplicity, it performs well in any classification task. It assumes that features are conditionally dependent given by the class label. And the third one is decision tree classifier. Decision tree classifier is a tree-based algorithm that recursively splits the data into subsets based on the most informative features, and each leaf node represents a class label within it. And the fourth one is perceptron. The perceptron is a basic neural network model consisting of the single layer of artificial neurons. It is used for binary classification tasks and is capable of learning the linearly separable patterns. And the fifth one is neural network. Neural networks are a more complex model that consisting of the multiple layers which are interconnected with the neurons in it and learning complex non-linear relationship in the data and are widely used for the various machine learning tasks. And sixth one is Ensemble SVM plus NB plus NN. Means of ensemble methods combine the prediction from the multiple models to improve the overall performance. In this case, the SVM, naive Bayes and neural network classifiers are combined and their predictions are aggregated to as of single one. And the seventh one is Ensemble SVM Perceptron plus N. Similarly, in the previous step, in this also the ensemble method is combined from the predictions of the multiple models to improve the overall performance. In this case, we combined the SVM, perceptron and neural network classifiers to leverage the strength of each model. And the building pickle file with the help of SPM classifier. After training the SPM classifier on the heart disease dataset, a pickle file is created to store the trainer model. The pickle file is a binary format that allows for each saving and loading of trained models. By building and saving the SVM model in a pickle file, it can be used later for making the predictions on the new unseen data without retraining the model from the scratch, and it can be saving the computational time and resources too. And another step is training the model. In this step, the machine learning models including the SVM, naive Bayes, decision tree classifier, perceptron, neural network and the ensemble methods are trained using the hard disease dataset, and the model learns from the input data and the corresponding labels to make the accurate predictions. And then the user gives the input. In this step, the user provides the input data from the heart disease prediction using the Flask framework. The input consists of relevant features such as age, gender, blood pressure, cholesterol levels, and many more. And the next step is the given input is pre-processed for prediction. Before using the trained model for prediction, the user provided input need to be pre-processed to match the format used during the model training. Pre-processing include handling the missing values, scaling and feature transformation to ensure the compatibility with the models. And then another step is trained model is used for prediction. Once the user input is pre-processed, the training models including the SVM classifier stored in the pickle file are utilized to predict whether the user has heart disease or not. Each model makes a prediction based on the input features, and the final step is final outcome is displayed. The predicted result, that is whether the user is predicted to have a heart disease or not, is displayed to the user. The outcome will depend on the predictions made by the individual model or the ensemble models depending on this approach used. The user take appropriate action based on the prediction results. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The dataset folder contains of the data files which we are using the 4 different datasets like of Cleveland, Hungarian, Switzerland and Long Beach dataset. And the static folder contains of the CSS, JavaScript and Bootstrap files and the images within it. And the template folder contains of the HTML document it of various like home, index, result, sign in and sign up pages. And the app.py file is an containing the logical information that related to the front-end logic. It could include the code written in Python that handles the server-side operation such as processing the user request, interacting with the database, and generating the dynamic content to be rendered in the HTML templates. And the notebook is an IPYNB file which contains the combination of code, graphs, and output all in one place. It allows the user to write and execute the code in individual cells, making it a popular choice for the data science. And signup.db, this file appears to be the database file used to store the user information. For the execution of the project, first we need to copy this address of the code folder and open the command prompt. Here we need to specify the disk location, and our folder is present in fdisk, so that's why I'm changing the cdisk to fdisk by this command. And after that we need to write a command that is cd space and paste this code folder address and click on enter button. And after this we need to write another command that is python space app.py. This python app.py is a command that user to execute the Python script and perform a runtime check for any syntax errors or logical issues. And click on enter button. By this, it running on the app.py file. The Flask framework will host the application locally at the default address like this. And we need to copy this local link and that is provided by the framework and paste it onto any web browser. And I am preferred to use of Chrome and pasting this web local link on this and click on enter button, and this is the home screen we got from this. And here click on the sign up button to initiate the registration process. After clicking on it, it will take you to the registration page as of like this, where we provide the necessary details to create the new account. But my account is already created, that's why I'm using the sign in button to log in it. And I'm entering the details as of admin for the user and the password and click on sign in button. And it redirected to the page where it contains the features columns to enter and the title of this and the sign out button too. And here we need to enter the name as of the user, and my name is Pregna and age is 21 and sex is female and CP is of 1 and rest BPS is of 115 and Chol of 0 and FPS of 1 and rest ECG of 0 Taraj of 110.243 and Exang of 96.3 and old peak of 0.2 and slope of 0 and CA of 1 and tal of 3. After entering all the columns, then click on submit button. Here it redirected to the another page where it gives the prediction as you have a chance of having the heart disease. In this way, we predict the heart disease by using the different features on it. And the conclusion of the project highlights the significance of accurate heart disease prediction given its status as a major chronic illness that can lead to the fatalities if not detected early. The research primarily focused on machine learning classifiers and introduced a majority voting based ensemble voting scheme for precise heart disease prediction. The ensemble schemes have been introduced in the field of data mining for around 18 years. The proposed ensemble scheme demonstrates the superior average accuracy compared to the other ensemble schemes and individual classifiers. The project supports that the developed framework has the potential to serve as the clinical decision support system, contributing to improved patient safety by minimizing the medical errors.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.